Okay, so the intermediate value theorem is something that now that we have continuity, we can talk about the intermediate value theorem. The intermediate value theorem is not very difficult to understand. We're going to do a set of about 4 different types of problems to help you hopefully have a better shot at getting some of these points on the AP Calculus exam. The AP Calculus exam definitely loves to bring up the intermediate value theorem from time to time. So it starts with this premise: let f be continuous on the interval AB and f of A not equal to f of B. Give me the stupid definition for continuity. And you don't pick up the marker, right? So that's the whole idea. So I've got. I told you, give me the stupid definition. I didn't say it was smart. Okay, so. No, I would not. No. So. All right. So by looking at the function, you can tell that A is continuous. You can see it's defined on the interval from A to B. And you can see that f of A is not the same as f of B, right? For every number n such that f of A is less than n, which is less than f of B, what does that mean? It's in between f of A and f of B, right? So for every number n that sits between f of A and f of B, there is a value C in the interval AB such that f of C is equal to n. What that means is this value n sits between the two y values, right? If it does, then the input value must sit between A and B. Can't sit outside of it, must sit in between it. Okay? Does that make sense that that has to happen? A little bit, but this is based off continuity. So the first type of lesson, what we were doing is showing that the limit exists. Now that the limit exists, we have continuity. There's a different way to talk about continuity as well. So we'll use this example right here. I have A and I have B. Okay, you don't have to draw this, but I'm going to have f of B and I'll have f of A. Okay, and so we're going to have a spot right there. We're going to have a spot right here, and we're going to have a number n that sits between them. So number n will be right here, okay? All right. Now here's the deal. Can I get from this point to that point without crossing over that? All right. Very good. So Levi says, doesn't pass the vertical line test. Levi's a fun killer. Okay. All right. Okay. So like this, like that. All right. Yeah, baby. All right. Right there. Okay. All right. Okay. I mean, we crossed over the value end, didn't we? I mean, well. Oh, thank you, thank you, thank you, thank you, thank you. Finally. But now it's not continuous, so it fails the continuity definition. Oh, does anybody want to come try to make, try to do it, make sure that this works out? Oh, you're saying it's impossible. What? Yeah. You can do it? All right. Spencer says he can do it. Well, and you have to get from A to B, and it has to be a function, and it has to be continuous, and you can't cross over n.
Oh, yeah. Okay. I won't lift my marker
up. Whoa! All right. Very good. So he definitely still crossed over, right? I mean. Yeah. 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 It's impossible, right? It's impossible. It's what the intermediate value theorem says. The intermediate value theorem basically says this. If you want to get from point A to point B, you have to cross over every other value in between. Okay? All of these y values between f of A and f of B must be attained. And so the IVT speaks forth. Let's see some good application of the IVT. Let's look at this. It says, explain why the function has a 0 over the given interval. What does it mean that this has a 0 over the given interval? What does it mean that this function has a 0 over this interval? What does it mean for a function to have a 0, period? Yeah, it crosses the x-axis. So you could plug in some x value and get 0. So what it's saying is there's some number between -2 and 1 such that when you plug it in, you get 0. We're going to show that that's true. What's f of -2? So we got -8 minus 2 would be -10 plus 2 is -8. Yeah, Carter. All right. What's f of 1? 4. So at the beginning of the interval, we start at -2. Okay, don't draw this. I'm sorry. Undo that. We start at -2 and we end at 1. And it starts for a value of -8 and goes all the way up to 4. So that means we got to go from here to here. Can we do that without crossing the x-axis? No. So let's explain. Because -8 is less than 0, which is less than 4. The IVT, meaning the intermediate value theorem, guarantees what? Guarantees a point, a value C, we'll say. What about that C? It's got to be between what? -2 and 1, right? So here's shorthand. So we're going to show you some shorthand mathematics. So you don't have to write so much. A value C in you're a backward epsilon. Okay, this is That's a symbol for in. In. Negative 2, 1. Such that. This is such that. Okay, this is such that. Such that. Such that. Okay, just then write such that. I don't care. Don't use my shorthand. In. Such that f of c is equal to what? 0. What? What are you talking about? How about you write it down and make a note? Okay, all right. All right, so let's try another one. F of 0. What's the sign of 0? Oh boy, it's 0. It is 0, and 3 times 0 is 0 plus 1 is 1. F of 5 pi over 4. Okay, what's the sign of 5 pi over 4? Anybody know? Negative root of 2 over 2 times 3 is negative 3 roots of 2 over 2 plus 1. So, for those of you who have no idea, 3 times the sine of 5 pi divided by 4 plus 1, we get negative 1.12. So if I have to go from a y value of 1 down to a y value of negative 1.22 or 12, I must cross 0 somewhere, right? So very good. Because, yep, negative 1.12 is less than 0, which is less than 1. The IVT, intermediate value theorem, guarantees guarantees a value C in what? The interval 0 to 5 pi over 4 such that what? F of C. Yep. In. There's a here's another symbol that we use in mathematics. This means that's for all values. All right, verify. So I don't have to explain here. It doesn't say explain. I just have to verify that the IVT does guarantee there's a 0 and find the 0 by using a graphic calculator. So I want to guarantee there's a 0 between negative 1 and 2. So I'm going to punch in negative 1. What do you get? Plug in 2. What do you get? 13. If I want to go from 13 to 1, do I have to cross over 0? IVT does not apply. What's f of negative 1? Yep, negative 1. What is f of 2? It is 2. So, does there have to be a value? Yeah, now, carefully look at your function. Is this function continuous everywhere? No. For what value is it not continuous for? Negative 2, but is negative 2 in that interval? So it's continuous over this interval, but if the interval instead of negative 1 to 2 is negative 3 to 2, then we would say the IVT does not apply again. We'll find that when we get back. Go get some lunch, get some brain food, come back smarter. Tell Sammy he has an awesome shirt, because it's an awesome shirt. Tell Brenda she needs a new shirt. Okay, does this function have to have a 0 over that interval? Why? So you get from negative 1 to 2. In order to get from negative 1 to 2, you got to cross over 0. Let's find it. We use our graphing calculator to find it. We could solve for it algebraically, but if I type in 4, negative 4, divided by parentheses, x plus 2, and then I add 3 onto that. You can see we talked about the discontinuity right here, but is negative 2 part of the interval? So then we don't need to worry about it. The intermediate value theorem does apply. I go second calculate. What? 2, the 0. I go to the 0 and I go to the left, and I go to the right, and I press enter on guess, and I come up with negative 2/3. So f of negative 2/3 is equal to 0, or my x value is negative 2/3 for the 0, okay? No, that's fine. Yes. So if I have 0.5, okay, and you want to convert that to a fraction, so math, convert to fraction. All right. I have many more tricks for you on the graphic calculator. Okay, verify the intermediate value theorem applies to the indicated value of C, then find C guaranteed by the theorem. So we don't want to guarantee that there's a 0. We want to guarantee that there's a spot where the function is equal to 6 over that interval. So what should I do? Plug in what? Negative 1, and I get negative 1 squared is 1 minus 4 is negative 3 plus 1 is negative 2. And then if I plug in 3, I get 9, 12 is 21, 22. So does it have to cross 6 at some time? It does. So now what we're going to do is we're going to find where it crosses over 6. And I just go x squared plus 4x plus 1 is then equal to 6. Yep, x squared plus 4x minus 5 is equal to 6. X minus 1, x plus 5. Whoops, sorry, 0. Okay, you get this, right? I'm wondering, when is this equal to 6? The answer is not extraneous. It's simply, starts with an I. Interval. Very good. Negative 5 is not in the interval. The function does have a value of 6. It's a parabola, so it's going to have that value twice. But 1 is outside the interval. 1 is inside the interval. So we found out that C is equal to 1. Look carefully at letter B. Anybody see anything interesting? Okay. What are the two conditions that must be satisfied for the intermediate value theorem? It must be a function, and it must be what kind of function? So with a C. Continuous. Is this function continuous? Or is it discontinuous? 3. Is that in the interval? So is this function continuous over this entire interval? No. So does the intermediate value theorem apply? No. Okay. We're going to, one thing we can use the intermediate value theorem from is when we talk about continuity. So we're going to do one more problem involves the intermediate value theorem. That's number 5. But right now we're going to just review one problem from yesterday, and we're going to show continuity here, okay? And so do you remember the 3 conditions for continuity? F of A must exist. Second one. The limit must exist. F of A must exist. And then the limit as x goes to A of f of x must equal f of A. So if you plug in A, you get f of A. All right, so let's show that this is continuous. First condition. What is f of 1? Yeah. If you plug 1 in, you get 3. Everybody agreed? Okay. I'm going to draw a graph to help us with the rest of this. I have negative x squared plus 4. So I'm going to plug in 1. And we plug in 1, what do you get? Positive 3. Open or close circle? Everybody okay with that graph? So what then is the limit as x approaches 1 from the left? Everybody agree? Now I'm going to move to the bottom one. 1 half x plus 5 halves for x greater than 1. I plug in 1. What do you get? We'll get there in a second. Plug in 1, what do you get? 3. Open or close circle? Open. And it has a slope of a half. So head off like that. So what is the limit as x approaches 1 from the right? 3. So what then is the limit as x approaches 1? It is 3. Okay, we checked from the left, we checked from the right. We also checked f of 1 was equal to 3. So finally, the limit as x approaches 1 of f of x is equal to f of 1. And that is 3. So we've proved the continuity. That was the middle one. So I did the top one, I did the bottom one, but then to finish it off, I went to that middle one. And I did that because I wanted to show the left and the right-handed limits first together. Okay, so we proved that it's continuous. Last example. Let's use the intermediate value theorem to try to prove that there's a number that is exactly 1 more than its cube. A number that is 1 plus x cubed. Can you think of a number that would work? Does 1 work? No. 2? No. No number would work. Maybe it's a decimal. So you can't think of a number, can you? It might be a fraction. We wonder what it is. Well, I'm going to show that there is a number. If I can show that that has a 0, then I've shown that there's a number that is 1 more than its cube. Right? Well, I know how to show that that is a 0. I'll just pick an interval. Is there a number you could think of that we could plug in for x that would give us a negative value? And a number that we could plug in for x that would give us a positive value? If I plug in -1, that gives me 1. So I guess -1 could be there. So we'll go with your -1 gives me 1. You went -4? Okay, we'll do -4. A -4 would be 5 plus -64, which is what? -59. Okay. All right. No, that's fine. What? I think I did. I think I went. Didn't I go? Okay. So we went from -59 to 1. That means we had to cross over every value in between, which includes 0. Because -59 less than 0, which is less than 1. The IVT guarantees what? A C value in such that f of c is equal to 0. Now we've said that it's going to be between -4 and -1, right? Well, I said 1, -4 and -1, right? So let's look here. If we go 1 minus x plus x cubed, if I look at that and I look at the graph, does that look like it crosses between -4 and -1? Yeah, in fact, if I calculate the 0, you can see yeah, -1.324718 is exactly 1 more than its cube. It's saying that if you take -1.324718 and you cube it, see how its cube, this is 1 more than its cube? It's 1 more than its cube. We were able to prove that that number exists, and we found it. Okay. All right.